Hello, in today's class, we'll discuss about instantaneous center. So when two bodies are moving in a direction, it has some constant point, these two constant points, which has an absolute velocity. So whenever there is a pair of constant points with same velocity, it's moving. So at that time, you need to locate the center of rotation for that relative motion. So this ICR will represent relative motion of link 1 with respect to link 2. Okay. So there is one common point there. The absolute velocity you need to find out for that particular relative motion between the linkages. So for that, first we need to understand different properties related to this instantaneous center of rotation. So when we are locating this part, when one digit is rotates instantaneously for given configurations of mechanism, at that time you can locate the ICR. That two body must have relative motion. The instantaneous center may be changing depending upon the rotation of both the links. Okay, and velocity vector is perpendicular to rotation radius. Now, to calculate the number of instantaneous center of rotation for given mechanism, we have one equation. From that equations, we can identify how many instantaneous centers of rotations are available for that given mechanism or given configurations, we can say. That equation is n is equal to n into n minus 1 upon 2, where n will represent your number of links. So in our case, if we look at these 4-bar mechanisms, we have 4 linkages. And for that 4 linkages, we can put that equation of n is equal to n minus 1 upon 2. If we put that part of 4 into 4 minus 1 upon 2. So we have 6 number of ICRs that is required to represent the overall relative motion of the linkages. Okay. Now, these are the linkages. Now, just I will tell you how we can look at this part. So first, the fixed ICR means ICRs which are associated with these linkages, fixed linkages, that ICRs are known as fixed ICRs. So we have link 1 and 2 connected at this point. Then we have link 1 and 4 connected at this point. So whenever we are locating the ICRs will also, we can locate the part from input to output movement. So this link 1 is motion will get transferred from 1 to 2, 2 to 3, and 3 to 4. That one is only supporting link, but we have to consider relative movement between the linkages. So ICR at that pin joint will be I12 for link 1 and 2. For link 2 and 3, it will be 2, 3. For link 3 and 4, it will be 3, 4. And for link 4 and 1, it will be 1, 4. Okay. So this is not 4, 1, this is a 1, 4. So we are saying that fixed ICRs are ICRs which are associated at this location, 1, 2, and 1, 4. These are the fixed ICR. Permanent ICRs means ICRs which are available on intermediate linkages. These are the permanent ICRs. And there is one more part, neither fixed nor permanent ICRs, which we need to determine to find out the relative motion between the intermediate linkages. Okay. And these ICRs are nothing but I24 and I13. Okay. So if we extend this line number 2 and line number 4, then we have this relative motion between 2 and 4, and that will be defined by I13. Similarly, if we extend this line 3 and 1, then we have this I24. So this I24 and I13 are the ICRs which are neither fixed and not permanent. So these are the 6 ICRs which we can locate, and these are the 3 different types of ICRs we need to plot whenever we are marking different number of ICRs for given configurations. So fixed ICRs, permanent ICRs, and neither fixed nor permanent ICRs. Now to get that relative motions, we have one equation which equation of Kennedy's theorem. That equation was derived from Kennedy's theorem. What is that Kennedy's theorem? If 3 bodies have relative motion related with respect to each other, then the ICR must lie on the straight line. Okay. Now look at the arrangement. The ICR of this, suppose we have this gear mechanism which is connecting at point A. And we have this linkages, fixed linkage 1. This is your second component, link number 2. This is your third component. And the tangential velocity component is tangential to motion. So it will be VA2 with respect to link 2, and this will be VA3 with respect to link 3. Okay. Now ICR for that part will be I12 relative motion between 1 and 2. Relative motion between 1 and 3 will be I13. Okay. And to get that overall number of ICRs required for the component will be n is equal to n into n minus 1 upon 2. So 3 into 3 minus 1 upon 2. So this 2, 3 will be your combined relative movement between link number 2 and 3. So it will be I2, 3. So in this way, we can determine 3 ICRs which are required to find out relative motion between the these 2 components. Okay. Now one more part is there. Suppose if we have this arrangement, this kind of arrangement. Now how we can locate the ICR? Just find out first the number of linkages available for given configurations. So we have link 1, 2, 3, 4. We can first go with the calculations, that is how many ICRs are required to determine the moment. So we have 4 into 4 minus 1 upon 2. It has 6 ICRs. Now to plot the ICRs, we'll go with circle diagram. In circle diagram, we'll locate the linkages. So we have 4 links are available for given configurations. So just divide that circle into 4 parts. So this will be 1, 2, 3, 4. While plotting that component on the circle, just take equal and opposite components in that circle and we'll get that line 1, 2, 3, 4. Okay. Now, how many ICRs are available? That we have to draw with dotted line. So what we have ICR 1, 2 at this location. So we'll draw straight line. We have ICR 2, 3. So again, we'll draw straight line. Then we have ICR 3, 4. So again, we'll draw straight line. We have ICR 1, 4. So again, this will be ICR line 1, 4. Okay. And just look at the flow. This is 1, 2, 1, 4, 2, 3 is there, 3, 4 is there. And this is link 1 and this is link 3. Okay. So there is a neither fixed nor permanent ICR is available for link 1, 3. And neither fixed nor permanent ICR is available for 2, 4. Now how we can plot this? Just to plot 1, 3. This is a 1, 3 line. We need to extend 1, 2 and 2, 3. So where is our 1, 2 point? This is our 1, 2 point. This is 2, 3 point. This is the first part. Second, extend 1, 4 and 3, 4. So this is 1, 4, 3, 4. So intersection of 1, 4, 3, 4 and 1, 2, 2, 3 will define position of I, 1, 3. That is your neither fixed nor permanent ICR. Similarly, to plot these 2, 4, just again it will form 2 triangle. One will be 1, 2, 1, 4 triangle. Second will be 2, 3, 3, 4 triangle. So just look at the flow. Where is 1, 2? This is 1, 2 and 1, 4. Just extend that line of 1, 2 and 1, 4. Okay, then we have second more pair related to this 2, 3 and 3, 4. Again, extend this 2, 3, 3, 4 line. So extension of both these lines will define position of I, 2, 4. So in this way, we can locate neither fixed nor permanent ICR I, 2, 4 and I, 1, 3. Okay. Now, while evaluating the available ICRs, we'll locate this table where one part is representing link, second part is representing relative motion. So for link 1, how many relative motions we have? We have I1, 2. There's a relative motion between 1 and 2. Okay. Then we have 2, 3 and 3, 4. Okay. So if you rotate 1, then 2 will rotate, then 3 will rotate. Similarly, to rotate this part, okay, so I will show this. So for this 1, 2, motion will be 1, 2 to 1, 3, 1, 3 to 1, 4. Okay. Movement will be transferred from 1, 2 to 1, 3, 1, 3 to 1, 4. Similarly, from 2, motion will get transferred from 2 to 3, 2 to 4. And for 3, motion will get transferred from 3 to 4. So in this way, we have these 6 ICRs. And these 6 ICRs we are representing on these lines. Okay. And we can find out the relative values also. Okay. So this is all about this first part, how to find out ICRs related to this 4-bar mechanism. Now suppose we have one more component. We have one more component, slider cam mechanism. Now in this slider cam mechanism, again number of linkages are 4. Okay. So these are the 1, 2, 3, 4 linkages. Now ICRs will be for link and 1 and 2 ICR will be I1, 2. For link 2, 3 ICR will be I2, 3. For 3, 4 it will be 3, 4 and 1, 4 ICR. For slider, 1 ICR is there, which is at infinity. Because slider is continuously moving and it is difficult to trace the relative motion between that turning point of link number point on link 4 and 3. So it will be I1, 4 at infinity. So again, we can find out the number of ICR required. N is equal to N into N minus 1 upon 2. Okay, so it will be 6. So just divide this circle again into 4 parts, then locate 1, 2, 3, 4 parts. All the ICRs are 1, 2 is available, 2, 3 available, 3, 4 is available, 1, 4 is available. Missing for nor neither fixed nor permanent ICRs are only I1, 3 and I2, 4. So just to locate I2, 4. Okay. I2, 4 again, how we can locate I2, 4 extend 1, 2, 1, 4. So this is 1, 2, 1, 4 line and 2, 3, 3, 4 line, 2, 3, 3, 4 line. So it will provide location of I2, 4. Similarly, if you want to locate I1, 3, extend 1, 2, 2, 3 line, 1, 2, 2, 3 line, you can extend and extend 1, 4, 3, 4. So this is 1, 4, 3, 4. So it will provide the value of I1, 3. Okay. So in this way, for slider cam mechanism and 4-bar mechanism, you can determine the orientation. Now look at the flow. Suppose if you have this 4-bar mechanism, Okay. So what kind of data will be available? The length of the link will be available. Let's say AB is given 150, BC is 180, CD 180, fixed link 300, link of AB makes an angle of 60 degree with fixed link rotation will be given. And the question is locate all the ICR. So again, we can go with the calculation. VB is 2 pi upon 60. So angular velocity is 10.47 radian per second. Velocity is r into omega, 1.57 meter per second. Okay. Now, first we have to locate the available ICR I1, 2, 2, 3, 3, 4, 1, 4. Now it is asked to calculate angular velocity of intermediate link. So it is V into r omega. So VB is available on both the part, AB and B. So velocity of B will be constant. So just divide by I13B for or to determine the angular velocity of the link number 3, that is omega BC. You will get that value 6.41 radian per second. And this will be I13B distance. So I13B distance means relative motion can determine a pi with respect to point P. V is equal to r omega. R is I13B part. So you get that omega. Similarly, linear velocity of CD we can determine I13C, that is orientation of this I13 with respect to C. And VC is omega BC, R into omega BC value we have, that is 6.41 radian per second into I13C distance, that is R distance that we can determine. And based on this, we can calculate angular velocity of point C, which is around 1.12 meter per second. Okay. So this way we can find out the linear velocity and angular velocity for link number 3, that is BC, and angular BC angular velocity can determine for link number 3, and for C component which is on link number 3 you can find out its linear velocity. Okay.